Good morning everyone. We are a group of two people, Lavanya and Anusha. Our experiment is determination of piezoelectric constant of a PVDF film. So these are the apparatus. This is the charge amplifier, multimeter, weights, and this is the experimental setup of the piezoelectric constant. This is the PVDF film which we are calculating the piezoelectric constant. And these are the two electrodes. So coming to the theory of the experiment, polyvinyl iodine fluoride, which is the full form of PVDF, it is a polymer. So when a film of this material is subjected to a uniaxial or biaxial axis stress and a high electric field is applied to it at high temperature, the dipole moment of the fluorine atoms align thermally parallel. So the dipole moment per polymer unit becomes larger. This is called poling. So when the specimen returns to a room temperature, the electric field and stress are removed, its piezoelectric constants become higher. Then in the direct method of measurement, one has to apply a stress, which is nothing but the weights we are adding, and measure the charge created by the stress. So when we are adding the weights here, which is nothing but the force we are applying, so that charge will be applied on the PVDF film. In ceramic materials, the elastic compliance coefficients Sij are in the range of 10 to the power minus 11 meter square per Newton, and the dimensions of the specimens are in millimeters. When the film is loaded or unloaded, equal charges of opposite sign are developed on the two faces. The measure of the amount of charge developed, we have built a charge amplifier. So the amount of charge accumulating on this PVDF film will be calculated using the charge amplifier, and that amount of charge we will be calculating through multimeter. Next, coming to the procedure. So first switch on the operators. And first the circuit is short and the output is set to 0 by offset knob. So first we have to do that. We have to short it. So we have to keep the circuit in short, and by using this knob we have to set the output to 0. So by using this offset knob, we have to set our output to 0. Next, we have to load our weight. This one weight is 0.5 kg. We have to load here. So before loading this, you have to keep it in open and load the weight. Before keeping the weight, you have to keep it in the open and load it. So this is our output. We have to write in the tabular column. So first we have to keep our circuit in the short, and by using this knob you have to set here 0 and keep it in the open and load the weight, and after loading the weight you have to note down the corresponding output in the tabular column, and same thing, and again you have to set to the short and load another weight. Keep it open and load it and note down the next value, and again make it short, and by using knob make it 0, and before adding just open it and add it and repeat the process continuously. So this is the loading. While doing loading you have to keep it in the forward bias, and for unloading you have to keep it in the reverse bias and remove the weight and note down the values. Repeat the process. So this is our tabular column where first column is our load. So we have to take load in kgs and newtons and corresponding voltage. We have to do 3 trials and we have to note the corresponding voltages. So when we add one weight, that is 0.5 kgs, the corresponding voltage for trial 1 is 0.778. And when we add one more weight, that is 1 kg in total, the corresponding voltage is 1.163. So repeat the same process and note the corresponding voltage and repeat the three trials. So for V average, we have to take the average of the 3 trials, and that is the V average. V total is nothing but the adding of each and every voltage, that is V total. And for charge, we have the formula, that is C into V total by 4.7. So where our capacitance is 110 into V total by 4.7, which will get 23.4 into V total. So correspondingly we will calculate the charge, which is 23.4 into V total, that is 0.736. We will get 17.225 for the first value. Repeat the same process for every weight. So now we will take the graph. Graph is between load and the charge. When we draw the graph, we will get a straight line. Calculate the slope. Here I got the slope 6.53 into 10 to the power minus 9 coulomb Newton inverse. So this is the formula for the piezoelectric constant, that is d31 equals to slope of the graph into AL by AC, where AL is the loads act on the area, that is the constant value, which is 28 micrometer into 16 millimeter, and AC is the metallized area, which is 12 into 30 millimeter square. So substitute these values in the formula, which is slope into AL by AC, and we'll calculate the slope. We got 8.09 into 10 to the power minus 12 coulomb Newton inverse. So this is our piezoelectric constant of the PVDF film. And then the result is slope of the graph, charge versus load, that is 6.53 into 10 to the power minus 9 coulomb Newton inverse, and the piezoelectric constant. This is our experiment.